Okay, inverse pairs. We are going to be proving that two functions are inverses. So to prove two functions are inverses at the top, it says they are inverse pairs if f of f inverse of x equals x and f inverse of f of x equals x. So the and is extremely important. And you'll notice the only difference from one side to the other is that we change the order. So if you do f of f inverse of x, you should get an answer of x. And if you do f inverse of f of x, you should get an answer of x. So this is how we are going to prove it. We are going to make a table. And on one side, we're going to do f of g of x. And on the other side, which this might take up space, so maybe don't draw your table yet. On the other side, you're going to do g of f of x. So we are going to take one equation and plug it into the other. So equation f, I'm going to make green, hopefully so you can still read it. And equation g, I'm going to make purple. So in this example, we are going to take equation g and plug it into equation f. That means you start with the f equation. You start with the 3 parentheses, but as soon as you see an x, you're going to set a new parentheses and you're going to write equation g. Square root of 5x plus 1 over 3 plus 2. So that's equation g, and I am plugging it into equation f. So now I need to finish my equation f. It was 3 times x, and then minus 2, parentheses squared, minus 1, and it's all over 5. Things like these parentheses and when it's all over the number or only partially over the number are super important. So the rest of this came from equation f. Keep your work super neat. Then we are going to start reducing or simplifying this. So there should be two numbers that are doing the opposite thing and are super close to each other with no other math in between. So don't write this down, but I'm going to circle something that does not cross out. This squared and this square root do not cross out because you're jumping over other math. You're not allowed to jump over other math. This 3 and this 3 do not cross out because you're going across a square root symbol and you're not allowed to jump over other math. So the numbers that are opposite and closest together are the +2 and the -2. You're allowed to cross out one thing, and it has to be the correct thing, and then you copy down everything that remains after you cross out that math. Make sure you keep all the parentheses where they were, etc. Then on the next step, you should be able to cross out one thing. This time, everything is under a square root, and that whole thing is being squared, so those cross out. And I write down everything that remains. Then, cross out something else. Only one thing at a time. I know I'm saying it in a super weird, annoying way, but that's because we get students that just cross out everything and say, oh, look, magic. That's not how math works. There is one correct step at a time, right? So here, because the whole thing's over 3, and the whole thing's times 3, the 3's cross out. 1 plus 1, how about 1 minus 1? Crosses out. And then we have 5x over 5, and the 5's reduce. And you just get x. I'm going to put a little check mark there. Notice it says prove they are inverses. Because they are inverses, at the very bottom, you should get an answer of x. That's what the definition at the top says. Okay, now let's do the other side. We are going to start with g. So start with the equation g on that side. But when I see an x, I'm going to use a parentheses and I'm going to write equation f there. So f is going inside of equation g. F says 3 times x minus 2 squared minus 1 all over 5. Okay, now I'm still finishing equation g. Notice I wrote too big, so I need to make that square root symbol go further because there's a +1 under the square root. The whole top is over 3, and then I need to make sure that my 2, +2, is clearly not under the square root. How you set this up is extremely important for the rest of doing the math. So we put equation F into equation G. Now we start simplifying. The closest math that's opposite. Again, I'm going to show you some things that don't work. This +1 and that -1, they're not on the same level, right? The -1 is up on a 5, so those aren't on the same level. Those can't be reduced. This whole thing is over 5, and it's all being multiplied by 5, so the 5's cross out first. Copy down everything that's left after you cross out the first piece. Now the ones are close enough together. They're on the same level, and I know there's a parenthesis here, but it's not doing anything, so the -1 and 1 cross out. Copy everything that's left down. These are worth a lot of points, you guys. And if you don't want to listen to me every time I tell you to copy it all down, that's great. You're just not going to get full credit. If you want full credit, you need to show every single step, one step at a time. 3 over 3, because that's all in parentheses, you can cross out the 3's. Now we finally got a square root over a whole thing being squared, so those cross out. And then the 2's are going to cross out for my last step. Okay, then you did all that work. You need to answer the question. So the question said, prove that they are inverses. So I'm going to give myself a tiny bit of room at the bottom. The table is most of my points, but then I am going to write since, with a C, f of g of x, it equaled x, but so did the other side of the table. And the nice thing about math is if two things equal the same thing, you can make another equal, and then g of f of x. And I didn't leave myself enough room at all. They are inverses. This sentence, since g of f of x equaled f of g of x, they are inverses. That's how you finish the problem and get full credit. Okay, let me show you a couple things, because sometimes students struggle with these, and there's a couple things to help us out. I'm going to use orange, and I'm going to write down the numbers I crossed out each time. Okay, so on the left, I crossed out the 2's. Then I happen to cross out the smaller 2's, right, the squared and the square root. Then the 3's, then the 1's, then the 5's. If you look at the right-hand side, the first thing I crossed out was the 5's. Then I crossed out the 1's. Then I crossed out the 3's. Then I crossed out the little 2's. And then I crossed out the 2's. If you look at the order you crossed things out, you will notice, yellow I guess, that the order I did it on this side is the exact opposite the order I did it on that side. And that's because they're inverses. They undo each other. So if you do both sides correct, you should check your work by making sure that the numbers are opposite. What you crossed off, the order you cross things off on the left is the opposite order you cross things out on the right. Also, let's look just at f of x. So I'm doing the left side of the table because we plugged things into f. F of x, I don't know why I'm writing it down. It's just right up there already, but was this, right? If you were to plug something in to f, what's the first thing you would do, right? So if I plug something into f, so as the x, it says x minus 2, so I would subtract 2. After that, I would square it. After that, I would multiply by 3. After that, I would minus 1. And then finally, I would divide by 5. If you look at the order of operations for the first function, which was green, right? At the top of my table, we did f of x, and I made f green. If I look at the order of operations for f, that is the order you cross things out for f. First you minus 2, then you do the square, then you do the 3, then you do the 1, then you do the 5. So hopefully that might help you out as well. You could do that same thing for g of x to do the right side of the table. If you look at the equation for g of x, first you multiply by 5, and I cross the 5s out first. Then you add 1, and I cross the 1s out second. Then you divide by 3, then you do the square root, and then you add 2. So it's the same order as the order of operations for the function itself. Okay, let's do another one. See if you can set up the table. Table always looks the same. Okay, so I'm going to do f of g of x on the left and g of f of x on the right. Just to be clear, you don't have to do it in that order, but you have to do both, right? Each order. Now see if you can carefully plug equation g into equation f. Setting it up is one of the most important parts. If you set it up wrong, you're going to start crossing things out wrong. So pause the video and see if you can set it up correctly. Okay, there's my setup. Notice the 7 is still clearly on top of the division bar and how everything is set up. If you guys aren't putting parentheses, if you're getting sloppy, you're going to start messing things up. Now see if you can figure out what the two closest numbers are that cross out. So again, let me show you some stuff that doesn't work. This 5 and that 5, you're jumping across a root symbol. You can't do that. This 7 and that 7, one of them's in a totally different level than the other 7. You can't do that. Hopefully you notice that this whole parentheses is cubed and the whole parentheses is under a cube root. So it is the cubes that you cross out first. Also, if you're looking at f of x, if you were to plug a number into this function, the first thing you would do is cube it. So it is the 3's that cross out first. Write down everything that's left. Show every single step along the way. See if you can figure out what you would do next. You can use the f of x on the left. So after you cube it, what would you do? Well, you would multiply it by 5. The 5's cross out next. After you multiply it by 5, what would you do? Well, you would add 7. The 7's cross out next. Then 2 over 2, and you get x. If you did the problem right, you will always get a single positive x as the answer because we are telling you to prove they are inverses. See if you can set up the right-hand side. See if you can plug f of x into g of x correctly. Okay, make sure it's all under that cube root. It goes all the way to the ground and all the way over the minus 7. So, I guess I didn't highlight these for you last time if you want to see that. I plugged f into g. So now you can look at g of x to help you out. G of x, again, I don't know why I just keep writing these down. It's right there. But if I was going to plug something in as x to g of x, what would cross out first? Or what would I do first? I would multiply it by 2. The 2's cross out first. What do you do next when you plug something into the equation g of x? You minus the 7. The 7's cross out next. Remember that root goes all the way to the ground? The next thing you would do would be divide by 5. 5 over 5 crosses out. And then once you get a cube root of something cubed all by itself, I didn't write down the 5's, the 3's cross out. And you have a single positive x left at the end. But if you don't show the work, you won't get credit. These questions are about the work and the order that you cross things out in. Then, since the left side equaled x, which also equaled the right side, they are inverses. And then you can check on the inside column. Left side went 3, 5, 7, 2. Right side goes 2, 7, 5, 3, the complete opposite order. Okay, we'll be practicing this a lot in class. If I haven't emphasized it enough, it's the order that you cross things out. You don't just get to cross them all out magically and think you're going to get credit for that. So make sure you take this seriously and you practice it with your teacher. I hope you guys are doing well.